Hello all. In this video, project management concepts of software engineering will be covered. The project management involves the planning, monitoring, and control of the people, process, and events that occur as software evolves from a preliminary concept to an operational implementation. So, for an effective software project management, it will be mainly focusing on the 4 P's, that is, people, product, process, and project. In order to effectively do project management, the project manager should understand the 4 P's, that is people, product, process, and project. Then the people must be organized to perform software work effectively. Communication with the customer must occur so that the product scope and the requirements are understood. A process must be selected that is appropriate for the people and the product. The project must be planned by estimating effort and calendar time to accomplish the work task. This is how a project manager is going to perform the project management effectively. So, first, you need to understand what are these 4 P's of project management. So, first one is people. The people is so important that the Software Engineering Institute has developed a people management capability maturity model, PMCMM. This was developed to enhance the readiness of software organizations to undertake increasingly complex applications by helping to attract, grow, motivate, deploy, and retain the talents needed to improve their software development capability. And this people's CMM defined has the following key practice areas, that is staffing, communication and coordination, work environment, performance management, training, compensation, competency analysis and development, career development, work group development, team or culture development, and others. And this People CMM or PMCMM is a companion of the Software Capability Maturity Model, which we have seen in Module 2, that guides the organization in the creation of a mature software process. So, this is also done along with the Software Capability Maturity Model's key process areas or key practice areas. That is about the people. Then the product. Product is something that should be known before a project is planned. That is, before a project can be planned, the product objectives and the scope should be established. Alternate solutions should be considered and technical and management constraints should be identified. So, all these things should happen before the planning of the project. Without this information, it will be impossible to define reasonable estimates of cost, an effective assessment of risk, a realistic breakdown of project tasks, or a manageable project schedule that provides a meaningful indication of the progress. So that's why we need to have a good understanding about the product. Then comes the process. The process, a software process, provides the framework from which a comprehensive plan for software development can be established. A small number of framework activities are applicable to all software projects. We know that framework activities that which we have seen in the last modules. Regardless of the size or complexity of the software, these framework activities are applicable to all the software projects. And there are a number of different task sets that enables it to be adapted to the characteristics of the software project and requirements of the project team. And along with this, there will be some kind of umbrella activities that overlay the process model. So we need to have a good understanding about the process also to effectively manage a project. And at the end it comes the project, basic understanding about the project. So we conduct planned and controlled software project for one primary reason: it is only known way to manage the complexity. So we conduct planned and controlled software project implementation so to manage this complexity. In order to avoid the project failure, a software project manager and the software engineers who build the product must avoid a set of common warning signs, understand the critical success factors that lead to good project management, and develop a common sense approach for planning, monitoring, and controlling the project. So, so we need to have a good understanding about the project also. So with a good understanding about the people, product, process, and project, you can effectively manage a project. So that is the first step towards the uh, uh, effective project management. So then you need to know how these things are done, how these people, process, product, process, and project are effectively managed. So first we will see about the people. So the software process is populated by players who can be categorized into one of these five constituencies. That is senior managers, project or technical managers, practitioners, customers, and end users. So every person or every player in a software process or a software project will come under any of these five constituencies. Senior managers who define the business issues that often have significant influence on the project, or a project or technical manager are those who must plan, motivate, organize, and control the practitioners who do the software work. And then practitioners are those who deliver the technical skills that are necessary to engineer a product or application. Then customers are those who specify the requirements for the software to be engineered, and other stakeholders who have a peripheral interest in the outcome. And the fifth one is end users who is going to interact with the software once it is released for production use. So to be effective, the project team must be organized in a way that maximizes each person's skills and abilities, and that's the job of the team leader. Okay. So leadership is an important aspect in project management. So here this is an MOI model for leadership which was suggested by Jerry Weinberg. MOI model means motivation, organization, and ideas or innovation model. Motivation is the ability to encourage technical people to produce their best ability. Then organization means the ability to mold the existing processes that will enable the initial concept to be translated into a final product. And finally, ideas or innovation is the ability to encourage people to create and feel creative even when they must work within the bounds established for a particular software product or application. So this is the MOI model of leadership. Okay. Weinberg also suggests that the successful project leader apply a problem solving management style. That is, a software project manager should concentrate on understanding the problem to be solved, managing the flow of ideas, and at the same time letting everyone on the team know that quality counts and that it will not be compromised. So that is the MOI model for leadership. Then another view of characteristics that define an effective project manager emphasizes on four key traits. They are problem solving, managerial identity, achievement, and influence and team building. So, problem solving. Problem solving is a key trait where an effective software project manager can diagnose the technical and organizational issues that are most relevant, systematically structure a solution, or properly motivate their other practitioners to develop the solution, then apply lessons learned from past projects to new situations, and remain flexible enough to change direction if initial attempts at problem solution are fruitless. So that are the problem solving skills required for the project manager. Then second key trait is managerial identity. Means a good project manager must take charge of the project. He or she must have the confidence to assume control when necessary and the assurance to allow good technical people to follow their instincts. So that is how a manager should take charge of the project and should have a managerial identity. That is the second key trait. Then third is achievements. To optimize the productivity of a project team, a manager must reward initiatives and accomplishments and also demonstrate through his own actions that the controlled risk taking will not be punished. Okay. So by rewarding the initiatives and accomplishments and risk taking, you can effectively manage. That is the third key trait. Then fourth is influence and team building. That is, an effective project manager must be able to read people. She must be able to understand verbal and non-verbal signals and react to the needs of the people sending these signals. So that is how an effective project manager can influence and build a team. And this is also another key trait in effective project management. That was all about the leadership. Then we have software team. The following are the options that are available for applying human resources to a project that will require N people working for K years. Okay. First one is N individuals are assigned to M different functional tasks. Relatively like combined work occurs. Coordination is the responsibility of a software manager who may have 6 other projects to be concerned with. Okay, that is one option. Then second option is N individuals are assigned to M different functional tasks so that informal teams are established and an ad hoc team leader may be appointed. Coordination among teams is the responsibility of a software manager. Okay, that is another option. And third option is N individuals are organized into T teams, Each team is assigned one or more functional tasks. Each team has a specific structure that is defined for all teams working on a project. Coordination is controlled by both the team and the software project manager. So that is the third option. So although it is possible to voice arguments for and against each of these approaches, a growing body of evidence indicates that a formal team organization, that is the third option, is the most productive option. Okay, that is how a team is built. Then the best team structure depends on the management style of your organization. The number of people who will populate the team and their skill levels and the overall problem difficulty, this all matters. Okay. Here it is a generic team organizations pattern. It was suggested by Manti. Uh, Three forms of team organizations, that is democratic decentralized team organization, controlled decentralized team organization, and third one is controlled centralized team organization. Okay, so we'll see what are these team organizations. Democratic decentralized means this software engineering team has no permanent leader. Rather, task coordinators are appointed for short duration and then replaced by others who may coordinate different tasks. Decisions on problems and approach are made by group consensus. Communication among team members is horizontal. Okay, that is democratic decentralized. Then controlled decentralized means this software engineering team has a defined leader who coordinates specific tasks and secondary leaders that have responsibility for subtasks. The problem solving remains a group activity, but implementation of solution is partitioned among subgroups by the team leader. Okay, it is controlled but decentralized. Then controlled centralized means top level problem solving and internal team coordination are managed by a team leader. Communication between the leader and the team member will be vertical, not horizontal. So that is controlled centralized team organization. Okay. Then we've talked about the team lead, different teams, how to software teams are formed, how the team organization happen. Now there will be some kind of coordination and communication issues that can occur within a team. So some project coordination techniques are categorized in following manner, that is formal impersonal approaches, formal interpersonal procedures, informal interpersonal procedures, electronic communication, and interpersonal networking. Formal impersonal approaches include software engineering documents and deliverables, technical memos, project milestones, schedules, and project control tools, change requests and related documentation, error tracking reports, and repository data. So that is formal impersonal approaches. Then second one is formal interpersonal procedures. It mainly focuses on quality assurance activities applied to software engineering work products. These include status review meetings and design and code inspections. Then third one is informal interpersonal procedures include group meetings for information dissemination and problem solving and co-location of requirements and development staff. Then third is electronic communication, which encompasses emails or electronic mails, electronic bulletin boards, and and an extension like video-based conferencing systems, etc. Then the last one is interpersonal networking. That includes informal discussions with team members and those outside the project who may have experience or insight that can assist team members. So that is interpersonal networking. So these are some of the project coordination and communication improvement techniques. Okay, that's all about the people or how the people in a project are managed effectively. Then the second P, that is the product. So, product should be understood before a project can be effectively managed. So, a software project manager is confronted with a dilemma at the very beginning of a software engineering project about this. Quantitative estimates and an organized plan are required, but the solid information will be unavailable. A detailed analysis of software requirements would provide necessary information for estimates, but analysis often takes weeks or months to complete. Worse than this, requirements may be fluid, that is, changing regularly as the project proceeds, yet a plan is needed. So, uh, therefore, we must examine the product and the problem it is intended to solve at the very beginning of the project. So, that is why the product should be understood at the beginning of a project. And at the minimum, you need to know the scope of the project that must be established and that should be bounded. At least that much should be done before a software project planning begins. So, the first software project management activity is the determination of software scope. The scope is defined by answering the following questions on context, information objectives, and function and performance. Uh, the questions related to context, like how does the software to be built fit into larger system, product, or a business context, and what constraints are imposed as result of the context. And questions on information objectives, like what customer visible data objects are produced as output from the software, or what data objects are required for input. And questions related to function and performance, like what function does the software perform to transform input data into output. Are any special performance characteristics to be addressed? Such questions are answered to establish the scope of a product or the software to be built. And this software project scope must be unambiguous and understandable at the management and technical levels. Okay, so this should be established and it should be defined unambiguously or which can be understood by the management and technical teams. Okay, and we need to bound this software scope. That is, a statement of software scope must be bounded. That is, a quantitative data like number of simultaneous users, size of mailing list, maximum allowable response time are stated explicitly, and constraints and limitations are noted, and mitigating factors are described in order to bound this software scope. That is the first step in project management. Then you start the problem decomposition. Problem decompositions can be also called partitioning or problem elaboration, and it's an activity that sits at the core of the software requirement analysis. That is, we are going to simply divide the problem into or partition the problem into smaller problems to so that it will be easier to implement. So during the scoping activity, no attempt is made on decomposing the problem. So decomposition can be applied mainly in two major areas, that is functional decomposition and process decomposition. That is, functional decomposition means the functionality that must be delivered is partitioned into smaller functions, and process decomposition means the process of software development will be partitioned uh, into smaller processes. So two types of decompositions can occur. The scoping activity uh, actually occurs naturally during the statement of the scope. That is, when you are establishing the scope of the project team learns that these functions are required for this particular product, then automatically a first level of partitioning naturally occurs. For example, the project team learns that the marketing department has talked with potential customers and found that the following functions should be part of the automatic copy editing, that is spell checking, sentence grammar checking, reference checking for large documents, section and chapter reference validation for large documents. Such kind of things should be there in an automatic copy editing method. So this becomes the first level of partitioning, or these are some of the functions of that particular system that we are going to develop, and each of these features represents a subfunction to be implemented in software, and each of this can be further refined or further partitioned into smaller problems or smaller functions if that decomposition will make the planning easy. Okay, so that is all about the product or the software that is going to develop that. So the product is basically the software or the system that we are going to develop. Then comes the process. The problem here, or the understanding a process, means now we know about the people and the product to be developed, and now we need to know how this product is going to develop, or how this software is to be engineered by a project team. So there will be a systematic process in this development, and the problem here is to select the process model that is appropriate for the software to be engineered by a project team. So we have already seen about the process models in previous modules. So we need to select the process model that is appropriate for a particular project. So the process model must be appropriate for the customer and the people who do work, characteristics of the product itself, and also the project environment. Then the team defines a project plan, decomposes the process into smaller processes, and the implementation begins. Okay, so you need to select the process model first, and then what we are going to do is you need to meld the product and the process together. So planning begins with melding of this product and process. So we have a software has different functions. Each function to be engineered by the software team must pass through a set of framework activities that have been defined for the software organization. Okay, so we need to meld between this product and the process of development. So suppose these are some of the framework activities defined by the organization, like customer communication, planning, risk analysis, engineering, construction and release, customer evaluation, etc. We have already seen this. That is, customer communication requires to establish effective requirement elicitation between developer and customer. Planning means the task required to define resources, timeliness, and other project related information. Risk analysis are tasks required to assess both technical and management risk. Engineering is the task required to build one or more representations of the application. Construction and release is the task required to construct, test, install, and provide user support. And customer evaluation is the task required to obtain customer feedback based on evaluation of the software representations created during engineering activity and implemented during construction activity. So, suppose these are some of the framework activities adopted by the organization. And you have a product to be built, and this we have understood the product, and we have divided the product's functions into smaller or we have decomposed the functions into smaller functions. So suppose we have this product functions and some product organizations process framework activities. We are going to develop a table like this, in which the rows represents the product functions and the columns are divided based on the framework activities, that is customer communication, planning, customer communication, planning, risk analysis, engineering, etc. So the job of the project manager is to estimate the resource requirements of each of this metric cell. That is, for this text input, you need to, for the product function text input, you need to estimate the resource requirements for each of the framework activity. That is, for text, for the product function text input, if it is having a framework activity customer communication, how much resources are required for that particular activity, framework activity. Then you take planning, how much resources are required for planning of this particular function text input. The risk analysis, how much resources are required for risk analysis of that particular product function. Similarly, you do estimate the resource requirements for each of this metric cell. Then also you have to plan a start and end date for the tasks associated with each of these cells and the work product to be produced as a consequence of each task. Okay, so that is how you are going to meld between the process and the product. Then the process decomposition is done. Relatively simple project might require this kind of work task, like develop list of clarification issues, meet the customer to address clarification issues, jointly develop a statement of scope, review the statement of scope with all concerned, modify the statement of scope as required, etc. So these are some of the work tasks for simple projects. If we are considering more complex project, this with which has a broader scope and more significant business impact. For such a project, it requires the following work tasks for the customer communication activity. Okay, it's just for one framework activity, that is customer communication. So these are some of the tasks in customer communication activity, that is review the customer request, plan and schedule a formal facilitated meeting with the customer, conduct research to specify the proposed solution and existing approaches, prepare a working document and an agenda for formal meeting, conduct the meeting, jointly develop mini specs that reflect data, function and behavior features of the software, review each mini spec for correctness, consistency and lack of ambiguity, assemble the mini specs into scoping document, review the scoping document with all concerned, modify the scoping document as required. So this is for a more complex product that is to be developed. So that is all about the process. Okay, process management. And finally is the project. In order to manage a successful software project, we must understand what can go wrong so that the problem can be avoided and how to do it right. Okay. So John Reel defines 10 signs that indicates that an information system project is in jeopardy or in a problem. Okay, so these are the 10 signs. That is, software people don't understand their customers' needs, the product scope is poorly defined, changes are managed poorly, the chosen technology changes, business needs change, deadliness are unrealistic, users are resistant, sponsorship is lost, the project teams lack people with appropriate skills, managers avoid best practices and lessons learned. So these are some of the uh, signs that indicates the system is not proper. Okay, so how does a manager act to avoid the problems just noted? So for this, a 5-part common sense approach to software project was suggested by Reel. So that is seen here. Okay, so the first part is to start on the right foot. This can be accomplished, or this is accomplished by working hard to understand the problem that is to be solved and then setting realistic objectives and expectations for everyone who will be involved in the project. It is reinforced by building the right team and giving the team the autonomy, authority, and technology needed to do the job. Okay, that is how we are going to start on the right foot. Then the second part is maintaining momentum. That is, many projects get off to a good start and then slowly disintegrate. To maintain the momentum, the project manager must provide incentives to keep turnover of personnel to an absolute minimum. The team should emphasize quality in every task it performs, and senior management should do everything possible to stay out of the team's way. So that is how they can maintain the momentum. Then the third part is tracking progress. For a software project, the progress is tracked as work products like specifications, source code, set of test cases. Uh, these work products that are produced and approved as part of quality assurance activity should be tracked properly. So, okay, so that's how you can track the progress of a software project. Then fourth part is making smart decisions. In the sense, the decisions of the project manager and the software team should be to keep it simple, that is, whenever possible, decide to use commercial off-the-shelf software or existing software components. Decide to avoid custom interfaces when standard approaches are available. Decide to identify and then avoid obvious risks, and decide to allocate more time than you think is needed to complex or risky tasks, etc. Okay, that's how you can make smart decisions. Then finally, the fifth part is conduct a post-mortem analysis. That is, establish a consistent mechanism for extracting lessons learned for each project. Evaluate the planned and actual schedules, collect and analyze software project metrics, get feedback from team members and customers, and record findings in written form. Okay, so this way you can conduct a post-mortem analysis of the project. So this is a way to effectively manage the uh, problems that can occur in a project. Okay, so that is about the 4 P's in project management. Thank you.